Okay, number 1, find h of x if it's going to be the functions added together. So this function plus this function. Everything on this test will be simplified. I will ask that in the instructions, so we should put stuff together if we can. And Nico, what else am I missing here? Not equals 0. H of x equals. H of x equals that. Yeah. Okay, so that was for you. Yeah, Miss Tana. Okay. I often get people who try to factor that. Factoring is a method for solving. You're not solving for anything. Factoring and simplifying are actually completely opposite of each other. So that's not what you're doing. Okay, another one. So f of x subtract g of x. And I wrote something specifically with a mistake. What is my mistake right now? Brackets. When you subtract, you have to subtract the whole thing of whatever you're doing. So really, you are going to have to do a minus x and a minus 3. And again, people see that and then they start trying to factor because they think it's a trinomial and they're solving for it, but you're not doing that. Okay, this one says to multiply the two functions. So this times this. Okay, I need you to do a whole FOIL system on that, right? A whole FOIL system, and then actually there's nothing else you can do. No combining terms. Okay, the last one is a division, so we have the f function divided by the g. Okay, when we've done this division, now we've created a domain problem. Does anybody see a problem with the domain, x values? There's a whole, so let's write that x cannot equal -3. Okay, and then if we have to do more info, we can talk about that it was a whole. So also, if I want this to be simplified, what can I do to simplify it? Because you can do some work with this equation. DOS, x plus 3, x minus 3, divide by, cancel. So there's the simplified equation, but I should probably make a statement that I still have that restriction where x cannot be a -3 still, no matter what. Okay, what if I went further and I said graph this new function? What does the graph of this look like? What is the shape it draws from your past experience? It is a line. And what else do you know about this line? The y-intercept is -3. And it's a 1x. So what kind of, what do you do with 1x? Staircase. But what else do we know here? At -3, there's a hole in our line. So this talks about the domain. What if I talked about the range of this graph? Is there any range issues? You have to jump over this hole, right? What is the height of that hole? -3, like this coordinate would be -3 comma, what? -3 plugged in makes a? -6, yeah. Okay, so if I asked you a range question, right, y is not allowed to be -6. You know how some of you like to write it like this?
Is it the same thing?
Same thing, yep. I mean, I could do the domain in that way, right, too? That's fine, same thing. Okay, so this is the equation-y stuff. I might tie it to graphs. I might tie in domain and range. All these things from your past are coming back. Which kind of operation changes the result? If you add, does it matter? No. If you subtract two functions, that's different. Right? That's different, but if you did an add, it wouldn't matter. What about multiplying? If you do the f times the g or the g times the f, does that matter to you? No. What about division? Yes. This versus this, that's different, right? So any kind of subtraction and division, you got to be careful about the order. Adding and multiplying, that order really doesn't matter. Okay, so if I give you a graph and you have to graph, you should do a system that has a table of values. Okay, so let's talk about our domain. Where do these both exist? Where do they both exist? What's the most left we would go that they both exist? -2. And then the farthest I can go with them both is 3. Okay, so get me all the f values. So we go from 0, -1, -2, -1, 0, 1. Okay, adding, I don't even need to look at the order. I just make sure I add the numbers together. Let's see what you can do here. That's a weird pattern. Did you get a 1, 1, 1, 3, 3, 3? Okay, so that's the graph. So the next one, please pay attention. This has an order. The F, subtract the G. You have to make sure that goes in an order. So subtracting. Did you get a V shape with a flat bottom? Okay, timesing. Your order will not matter, so just make sure you're timesing the two of them together. Sorry, you're a little bit off the map here. At the very bottom, I was a little bit off that grid, but on your test, make sure you always pay attention to saying, should there be an arrow on something or not? So obviously this one is not because there was no arrows. To have an overall arrow, do you understand you would have to have 2 arrows? Right? Does that make sense if I said that? Okay, last one is an order important. So this one has the F divided by G. That's good? So now I had a further question here. What if I had done a g of x divided by an f of x? Would there be any restrictions? So g of x divided by f of x. So what do we talk about with division? What's not allowed? You can't divide by 0. Is there any places where f of x is 0? At -2 and at 2. So yeah, there would be restrictions. There'd be restrictions. So if you had to have graphed that, what do you think would be on your graph? You would have vertical asymptotes. Okay? Okay, so this one we're adding. So this function plus this function okay, obviously you can't simplify this, but it just talks about the domain issues. Okay, what do you know about radical domains? So like radicals, this is a typical radical. So what do you always know about the domain? So like for this one, x would be greater or equal to some number, right? Does that make sense? Or you could flip that around, okay? But it's always a set of inequality like that. So what would you say here? X can be what there? It'd have to be greater or equal to -2. Is that what you picked? -2 causes it to be 0, which you can radical. And then anything above that is positive, so you can radical it, right? You have to be bigger or equal to this, except there's some other value we hit. X is not allowed to be a 3. Because now that's a division by 0. For those people that like it the other way, you can go from -2 and then up, but then once you get to 3, you have to stop, and then you can keep going up. Okay, so then this one would be this divided by this. Okay, we're looking at the same things. We can't have that radical. So we're restricted with the radical, we're restricted with this rational. Same thing. Okay, we are restricted with the radical again. We are restricted with the radical part, but now there's a new restriction in here yet. So that idea is the same, that idea is the same, and there's one more idea added, because now what? I also can't have this be on 0, because now I'm dividing by 0. So what else is bad? A -2. You can't be on -2. So how do I switch this answer from the other ones? Can't be on, not now. Okay, so there was one more thought about that one. Okay, so in this one, I say h of x was when I added 2 things. You got to create 2 things. You got to make up something for each, but when you add them together, they got to make that. So you pick. There's a million possibilities here. So here's some samples. I put them adding together, they make that. I add them together, they make that. Okay, you can have lots of options there. Okay, and then this means I need 2 functions. I'm going to create whatever I want, but they need to multiply to that. So what I'm going to probably think is a simple trinomial. What factor times what factor would get me to there? Right? If I do this times that, then I would get to that final answer.
What about the times 1?
Nope. Composite. Okay, I wrote here f of x is this line. Okay, there, I defined it down here. F of x was the line and the g of x is the v. Okay, number 1. What is the g of -3? So go on to the v shape, get to -3. What's the height? 2? So now the question will be, what's the f of 2? So now go to the line, get over to the x of 2, and what's the height? 3. Okay, on the line, if you are at 3, your height is at, would you say 3.5? I probably won't ask, you probably won't run into those kinds of things, but. Okay, on the V shape, can you go to 3.5? What height are you at? 2. Okay. -2 on the line. What's the height? 1. Okay, you're back into the F. So you go back to the line. If you go over to a 1, your height is 2.5. Okay, now you have a triple. What is the F of G of what? -1. So G of -1, go on to the V shape. -1, your height is 0. Is that what you got? On the V, -1, your height is 0. What is the F of 0? So on the line, when you are at 0, your height is 2. And now we got to do another F. So on the line at 2, the height is 3. Okay, last question here. What does this little symbol mean? Inverse. So what does inverse do? Okay, so what does this mean? This time, the 3 is the output, and you're trying to figure out where the height of 3 is. Okay, before we were trying to figure out the y, but now we're trying to figure out the x part. So on the line, where do you have a height of 3? At the x value of 2. So just 2 is all I want. But do you understand how to do this concept not on a graph, but on points as well? Like if I give you this is the same idea, it's just that I put them as coordinates instead of a graph. Do you understand how to follow that same idea? So what is the G of 7? The G of 7 is 0. Then what's the F of 0? Okay, does that make sense? Same idea, it's just from a graph to coordinates. Okay, this is also the same idea, but now it's on equations instead of graphs. So what is the G of 3? Can you put a 3 into that? So 3 squared minus 2 is 7. So now, what is the F of 7?
Do you have a highlighter? Yeah. We might have we're gonna have a quiz. Yeah. Yeah. Pretty sure we will. Thank you.
Yep. Okay, can I leave you A, B, C, D alone? Because my grade 10s are doing this exact same thing.
Come on.
Yeah, their test is tomorrow. This is probably the exact same question they're getting. So you can do A, B, C, D, and then we'll check. Okay, so the next one, I'm just going to write this out. Okay, so when you deal with functions, really, I wouldn't even think of this as x plus 1. It's essentially the input plus 1. Here too, this is not really read as x squared minus 2. You can think about it like input squared minus 2. It just happens that your input was x. But this is different. So we're going to put the g into the f. So we're going to take the g and put it into the input spot. Input plus 1. That's what I'm reading. Input plus 1. Okay. Next, we're going to do a different way, it looks like. The F is the input, and you're putting it into the G. So this has to go into input squared subtract 2. That's really what that is all about. The input squared minus 2. Okay, I am going to simplify that. So what does simplify mean? Multiply, collect, that's what simplifying is. Okay, do not square individuals here. What are you doing? Squaring the units. Okay, then down here, talk about graphing. I say to just graph this one, but why don't we graph both of them? We got lots of space on the paper, right? Let's just graph both of them for practice. X squared, got to know the shape, patterns. What else do we know here? There's a minus 1 after. So y-intercept is negative 1. And what kind of thing are you doing as a pattern? 1, 1, 2, 4, 3, 9, but that's good. Remember, on your test, I would expect some kind of tick marks or whatever. Okay, so then there's this one. Okay, so put lots of things you know together. First of all, when I look in this form, all I really know is the shape. I know a shape, and I know a y-intercept. That's really all I know when I look like that. I know the shape and I know the y-intercept. Okay, I don't really know what else to do. So I'm going to go back to this form. And that tells me the transformations. What do you have? Which directions are you going to shift this parabola? Up, down, left, right? What do you got? This is a C. So that would be left 1. And this is a D. Down 2. So left 1, down 2. Okay? Do you see all those things you've ever learned tying together? Left 1, down 2. I'm getting weird eyes. Am I doing something wrong? The parabola, the start of it is here. Left 1, down 2, you start. Because where does a normal parabola start? 0, 0. So then this starter has now gone left and down, the starter point. Yeah. Okay, last page here. Okay, so on this one, it's another composite. So this is put the F into the H. Put the F into the H. F goes into the H. So then here I can do a Y equals because it told me there was a Y equals there. It defined it, so then I can do that. What do you do when you graph? Radicals. Do you know what the radical shape even looks like? When I say what's the shape of a radical, you should visualize that as a shape, right? So, transformations. What do you got going on with this? Left 1. There's a left. And how does a radical move? What kind of pattern? 1, 1, 4, 2, 4, 2, 9 over 3 up, right? The opposite of a squared. Bless you. Should I go back to radicals and give you a harder one just in case?
Yes.
What if I told you to graph that radical?
You need to factor out.
Instantly, you need to factor out that 2. So you should look at it like this. Then, where do you put the starter on this radical? 3 to the left. Okay, so many people write left 6, but it's not. It's not left 6. Okay, let's talk about over up stuff. We just did this 1, 1, 4, 2, 9, 3.
X times 2. Divide by 2.
Divide by 2. Divide. Do you know that letter? A, B, C, D stuff? It's a B. What do you do with a B? Divide your X. So this would be a half. So I'm only going to move a half to the right and up 1. I'm going to move 2 and 2. I'm going to move 4.5 and then 3. Is that all coming back to your brain? Okay, so now it's a domain question. There's lots of domain questions on your test here. So what is the domain of this versus the domain of this? So this one we just did. So what was the domain of that? -1 to infinity. But it said, well, how is that going to be different if we do this equation? Okay, so I'm going to give myself this on my paper just so I can see it. So this one says put the h into this one is different. Is that the equation you got when you plugged it in? This is a radical. What happened to this radical transformation-wise? Up 1. This is an outside. So this is up 1. So guess what your radical will kind of look like? Just a general idea of what it looks like. So what is the domain? That's what the question said. Domain? 0. Okay, I just had, I think that was it, right? But I had one more important question. We worked on it at lunch. I don't know what page it was on.
Oh,
I don't really know.
Oh, like that one?
Yeah.
I can find it. It was page...
It was probably like this, hey? What was that? I'll just make this up because I think this is probably what it was. Okay, here's a question that was in your book somewhere.
Oh, page 11.
Page 11?
Question 6.
Did I nail the question? I was just making it up? Kinda?
It's x squared subtract 1.
Oh,
And then
okay.
the gx is x plus 1 squared root.
Oh, okay. Well, that's fine. This is good, too. Okay. There's something like this on page 11. The g of f of x. So what does it mean? Put this into that, right? Put this into that. So it would be this input squared. And then, what would happen with a square and square root? Cancel, and it would be x. How do you graph, so like, how would you graph y equals x? It's just a straight line. That would be y equals x. Okay? But what didn't we consider? Domain issues. Is there issues with our domain? Yes, because we had this radical. So what do you know about the square root of x? There's restrictions on that. So what is that restriction? You can't be negative. You have to be 0 or positive. So x is not allowed to be anything negative. So how should I actually draw my final graph? That would be my final graph. Does that make sense?